In this video, I'm going to introduce to you two examples on how to use our vocabulary from our previous video for this lesson. Finding the parts of the vertex, we're actually going to do those and with the formulas that we learned in the previous video. And then we're actually going to put them together and we are going to graph our parabola starting right now here in this video. So here we go. Steps for graphing are quadratic. So that means you have to have at least an x squared term, but you might have an x squared term and a linear term and a constant. So in order to be a quadratic, again, you have to have that square piece, but you may or may not have a linear and a constant. So I'm going to show you one that actually doesn't have the middle term here first. So number one, follow the above steps to find the vertex, which was actually, notice how this says part 2, so this is part 2. We're going to find our x coordinate of our vertex, which is also our axis of symmetry. We're going to plug it in to find our y value of our vertex. Then we're going to plot that vertex and the axis of symmetry on the coordinate plane, so your x and y grid. Number 3, we're going to make a table of values using x values to the left and to the right of the vertex. That might sound kind of silly, but I will show you exactly what that means. So our vertex is going to go in the middle of the table. So notice here, I'm going to put my vertex right in the middle, okay? And I'll review that when we get to that point. And then last, plot the points and connect them with a smooth curve to form the parabola. And again, it's a U-shaped curve, and I'll talk about that curve here. So example 2. Graphing a quadratic function with a positive or negative a value. Here, I have 1x squared, I have no x's, and I have a negative 1. So my a, b, and c, I have 1x squared, I have no x term, and my constant term is negative 1. So to get my axis of symmetry, what I need to have is what is called the opposite of b over 2a formula. Opposite of 0 is 0. It's not plus or minus, and double my a term, which is 1, is going to be 0 divided by 2, which is just 0. So my axis of symmetry is going to be at 0, which will actually happen to be our y-axis. So I'm going to write this as x equals 0, which is our axis of symmetry. And now I'm going to plug 0 into our function, and we're going to find our vertex. Okay, so if I plug 0 in here, I'm going to have a y value of 0 minus 1, which will be negative 1. So at negative 1, I'm going to actually erase my line right there so I can just make my point nice and visible. At 0, negative 1, that's going to be my vertex. Okay, now, min or a max. Depending on what type of a you have, if it's positive or negative, and I'll review that with you here, if your, where do I have it? If your a is positive, your graph is going to open up and you're going to have a minimum. So if my a is positive, I will have a minimum. So the graph is going to go up from here, so since it's positive, it's going to want to climb and go up, up, up. So that means it opens up. And next, I'm going to find my roots, and I'll show you how to find those with our picture. First, I'm going to use what is called my table of values. So I found my vertex, and I'm going to put that point in the middle of a T table. You can call it a T table because it kind of makes a T here, if you can kind of imagine that. And I'm going to put my vertex right in the middle. It was 0, negative 1. Now in the directions up here, I said, start in the middle of the table, make a table of values using x values to the left and to the right of your vertex. Now if my vertex is at 0, negative 1, to the left my x would be negative 1, and to the left it would be negative 2. To the right it would be positive 1, and to the right again it'd be positive 2. And what I'm going to do is substitute in these values into my function. So y was equal to your x value squared, and then you subtract 1. So what would be negative 2 times negative 2 and then minus 1? Well, that would be 4 minus 1, which will be the number 3. So a point on my grid is going to be the point negative 2 and up 3. So I'm going to plot that point over here. Now I'm going to do the same thing, and I'm going to substitute in -1. -1 times -1 is 1, and 1 minus 1 is 0. So -1, 0. So here's another point. And now I'm going to do the same thing, because I already know where my vertex is. I'm going to do the same thing over here. Right to the vertex. So if I plug in +1, because that's on the right side of my vertex, I'm still going to get 1 minus 1, which is also equal to 0. Notice there's some symmetry going on here. And, excuse me, 2 squared. 2 squared, 2 times 2 is 4, and 4 minus 1 is 3. Again, notice there's some symmetry going on here. I also got 3. So here is your picture. Now my graph's not perfectly through those points, but that's what your parabola will look like. Now I want to talk to you about what we call our pattern of change. Our pattern of change for parabolas. I'm going to zoom out just a little bit. From your vertex, what you want to look for is this pattern. And I hope this makes sense. So if your function is x squared, if you plug in 0, you're going to get 0. If you plug in 1, 1 squared is 1. If you plug in 2, 2 times 2 will get you 4. And if you plug in 3, 3 times 3 is 9. And if you plug in 4, 4 times 4 is 16. Again, 5 times 5 is 25. So that should make sense for squares. Notice from your vertex. From your vertex, if you go out 1, you're going to go up 1. 1 away from your vertex, you're going to go up 1. But if I go out 2, I'm going to go up 4. So notice how I go out 1, 2, up 1, 2, 3, 4. Now if I go out 3 from my vertex, because this is a quadratic, we said it's a square function. If I go out 3, I'm going to go up 9. So from my vertex over 1, 2, 3, up 1, 2, 3, 4, 5, 6, 7, 8. Oh, almost. It should have hit roughly here. Just off my paper. So the pattern of a parabola is going to be your squares. So from your vertex, out 1 up the square, out 2 up the square of 2, out 3 up the square of 3, out 4 up the square of 4, and so on. Now when your a is not 1, you adjust this by your a. So it's a times your pattern, 1, 4, 9, 16, 25, etc. So if your a is not 1, it's going to adjust that pattern by whatever your a is. And we'll explore that in future videos. But kind of just a cool pattern because we're dealing with squares. So those squares got to show up somewhere, and they show up in your pattern. Here is one more example. And I have a new function. So I have y equals -x squared plus 4x minus 4. So I have -1 for my x squared term, +4 for my linear term, and -4 for my constant term. And now what I'm going to do is find what is called my axis of symmetry. X is equal to opposite b over 2a. Opposite of 4 is -4. And double my a, or double -1, is going to be -2. -4 divided by -2 is +2. So x equals to 2 is my axis of symmetry. Okay, I'm going to put that down here because that's one of the things I got to fill out. It will also be the x value of my vertex. So to find my y value of my vertex, I'm going to sub 2 into my function. Opposite of 2 squared plus 4 times 2 and then minus 4. Before I can do my multiplying, I have to address the square. So exponent comes before the multiplying. And then before I do my add and subtract, I have to do the multiplying. So exponent, then the multiplication, then add or subtract. So this is opposite of 2 times 2, or 4. And then 4 times 2 is 8. And now I have -8, because those two 4's make -8, and I have +8. Or -4 plus 8 is 4, and 4 minus 4 is 0. So it's going to be at 2, 0. So I'm going to put that point on my grid here. I'm going to use a color this time. Hopefully that's a little brighter for you. And my axis of symmetry is not usually drawn, but it will be a vertical line that your picture completely is symmetric around. So the right side and the left side will look identical to each other. Kind of like, well, hopefully your hands are pretty symmetrical, but either way, it will look the same on both sides. Now look at your A term up here. If your A is negative, that means your parabola is going to open down. So the top of our graph is going to be our vertex, which will be a max, because our A is negative. It will open down. So that's important to note. Now, I'm going to find the roots after I draw my picture because I want to connect it to our picture. I didn't do maybe the best job over here, but your x-intercepts, your roots, look, I didn't even fill it out. It's where your function crosses the x-axis, and there are two of them here. X is equal to -1 and +1. You could label it as a point, but don't put these together in a point, meaning don't make it -1, 1. That's not correct, because you want to have x-intercepts, so your y value should be 0. Okay, let's finish this one. We're almost done. All right, now to get the other points on my picture, you can follow the pattern, but I haven't really discussed the pattern so much. So what I'm going to do is put my vertex in the middle of my table. My vertex was at 2, 0. Now at 2, a number to the left is 1. A number to the left of that is 0, a number to the right is 3, and a number to the right again is 4. So notice how I'm going to go in order, and my vertex is going to be in the middle. And that will help you kind of get your pattern to the right side and the left side if you put your vertex in the middle. So plug in to your function. So again, I'll write that down. -x² plus 4x minus 4. We're going to substitute in 0 here. 0 times 0 is 0. It's not going to be positive or negative because it splits the two positive and negative categories. Plus 4 times 0 is 0, and then minus 4, I get -4. Okay, now let's substitute in 1. All right. Oops, I don't need that parenthesis there. Let's get rid of that. Okay, here we go. 1 times 1 is 1, and then we'll make it opposite. 4 times 1 is 4, and then we'll subtract 4. These are going to cancel out, so I'm going to be left with -1. Here we go. I already know my vertex points. I'm going to skip that, so here we go. Opposite of 3 squared and plus 4 times 3, and then minus 4. Opposite of 9 plus 4 times 3 is 12, and then minus 4. -9 plus 12 is 3, and 3 minus 4 is -1. Notice how there should be some symmetry going on here. And last one, opposite of 4 squared, 4 times 4, and minus 4. Opposite of 4 squared, or opposite of 16, plus 16 minus 4. Oh, I like this because these will cancel out. I'm left with -4. Again, notice there should be some symmetry because it should be matching on the left and the right side. So with my grid here, I'm going to plot 0, -4, 1, -1, 2 zeros already done, 3, -1, and 4, -4. So here is your parabola. Notice that symmetry I was talking about. Your squares, if you go out 1, go down 1 squared. Well, 1 squared is 1. Go out 2, go down 2 squared, which is 4. Go out 3, go down 9. Now 9 is off my grid, but think about it. 1 squared is 1, 2 squared, 2 away from your vertex is 4, 3 squared makes 9. So that's the pattern you're going to see show up, again, when your A is 1, but when your A is not 1, it's going to alter that pattern slightly. Here we go. We started graphing quadratics. Great job.